Hello, ladies and gentlemen, boys and girls. Today, we're going to have a kind of a brief video on Ohm's law. All right, we're talking about electrical energy, and we're talking about the relationship between three different variables. We talk about electrical energy. We want to talk about electrical current, electrical voltage, and resistance, or as we talked about, like the flow of electrons, current, the push of those electrons, voltage, right? And the resistance, that's slowing down of electrons. Remember, all objects create some level of resistance, some more than others, insulators versus conductors. All right. And so when we have three variables here, we have to look at kind of two individual relationships, right? So if we're going to collect data on something, we only can do collect data on two variables at a time. But since there are three variables, we have to look at in two different relationships. And then what we're going to do today is combine those two relationships into one big relationship that we call Ohm's law. All right, so let's review some of the data of those relationships, put it together, and then we're going to apply it on a quick example over here. All right, so let's talk about it real quick here. So in this first example, we have the relationship between voltage and current. Voltage is that amount of push of electrons in volts, and then the current in amps is the amount of flow of electrons. As you can see here, all right, we have a constant relationship with the y-intercept being at 0. We have a constant relationship. As the voltage increases, the current increases at a constant rate. All right. If you were to calculate the slope of this line, it would stay the same throughout the entire voltage current. It would actually end up being the resistance of the circuit that you use to collect this data. All right. So in this case here, the voltage or the current, which we represent with the letter I, is going to be related to the voltage in a very direct manner. As this number goes up, this number goes up. If this number goes down, then that means that number went down. All right, it's a direct relationship. That's kind of our first relationship. All right, and our second relationship, where we kept voltage the same, we have the relationship between resistance, which we're going to measure in ohms, all right, and current, which we measure again in amps, right? So as the resistance increases, the current is decreasing, all right? That's why we get that kind of that negative slope. But in this case here, the relationship is not constant. It is a changing relationship. The slope starts off very steep and gradually becomes smaller and smaller, all right? In this case here, the current is not directly related to the resistance. It is inversely related to it. And that gives us our nice little curve here. All right. At higher levels of math, we can learn how to calculate that. That's not what we're going to do here today. So now we have two different relationships. We have this relationship right here. We have this relationship right here, which includes voltage, current, and resistance. All right. Current kind of be the middleman here in this case. All right. And what we're going to do is we're going to combine that into one big law called Ohm's law. And it's a pretty straightforward here. Basically, what we're going to do is we're going to take this idea and we're going to merge it with this idea. Both of these have current. So we're going to say that current is equal to, all right, it's directly equal to its voltage, but indirectly related to its resistance. Clean that up a little bit. All right, and there it is. That is our formula. It's a pretty straightforward one. This is the formula that we call for Ohm's law, where we have current measured in amps is equal to voltage in volts divided by resistance in ohms. This is Ohm's law. All right. Now, if we were going to then try and calculate it using a circuit here, all right. Let's say I have a battery that's providing. Let's say it's a 9-volt battery. So we have a voltage of 9 volts. All right. Let's say the combined resistance of the wires, the light bulb, and this is a resistor here. Remember, every object creates resistance. Let's say the complete resistance here is the resistance is going to be a total of 2 ohms. And I want to know how much current is going through that light bulb. All right. I need to know how much current is going through that. All right. So all I would do is use my formula, right? Where current is equal to voltage divided by resistance. That's 9 volts divided by 2 amps. That ends up being 2 ohms. My apologies. Makes 4.5 amps of current. All right, just applying a quick formula here. Basically, we got a formula which we derived using our relationships here. All right, and in this case here, we could also practice trying to solve for other variables. We could find the resistance if we know the current. If we know the resistance and the current, we could multiply them to find the voltage. We can rearrange that formula in different ways using some of our algebra skills. All right. So here we are. We have our constant relationship, our changing relationship to create our one big relationship known as Ohm's law. Practice applying it. If you have any questions, make sure this is all inside your guys' handy dandy notebooks. If you didn't understand something, please go back and look back at it. Otherwise, thank you very much for watching. Have a great day. May the science be with you.